As I said before, when you're talking about your region of possible solutions, it's all the ordered pairs that make every inequality in the system true. When we had just one linear inequality, the ordered pair had to make just that one true. But now we're talking about all of them. So if you look at this particular one, 4x plus 3y is less than or equal to 24. Y is less than or equal to 4. X is greater than or equal to 0. And then y is greater than or equal to 0. So whatever ordered pairs I find, every single one of these have to be true. Now, I'm not going to work, I'm going to show you the graph of all of these just so you can see what I'm talking about. I took this, it's in standard form, and I wrote it in slope-intercept form because then I could find the x-intercept, the y-intercept, and get the 2 points that I need to graph. Can I find the x-intercept and the y-intercept here? Absolutely. Absolutely. I just get in the habit of doing it this way just to show you that both ways it can be done. Place 0 for y, solve for x. Place 0 for x, solve for y. You can still get your points. Okay. All right. So let me show you what these graphs literally, what they look like. Okay. This is the whole system. So if I graph the whole system, the y-axis, here's the x-axis. This is where y is equal to 0. This is where y is equal to 4. This is where x is equal to 0. And then this is my blue line. So my lines match the graphs. All of my graphs are solid lines because it says less than or equal to. So that means it's not going to be dotted. It's going to be on the line or wherever we shade. So if I go through all of these and we have to figure out where to shade, let's look. So let's look at the blue line first. All of the points, all of the ordered pairs that make that equation true are on the bottom side. Okay, so all of this and on the line, anything over here is not going to make blue equation true. Okay, let's go to the green line. Anything below it, see, remember when we had that chart below it, see everything below that line is less than or equal to 4. Which makes sense. So if y is 3, y is 2, now if y is equal to 6, well, that's not less than or equal to 4. That's why we didn't shade right here. Okay, let's look at the red line. Everything greater than or equal to 0. Well, x equals 0 is here. So nothing on this side is going to be shaded because these are all negative x values. But everything on this side is shaded. Makes sense? And then y is greater than or equal to 0. So this is the y is equal to 0. So it's everything above it. Now, the region of possible solutions has to be where every ordered pair makes the equation true. So if you look at these, what is the common area that's shaded? So I'm going to put my cursor right here in the middle. Watch, this area is touched by every color. So first there's blue, green, right? Red, yellow. So that's my region of possible solutions. If I pick any ordered pair in this region, it makes every single equation true. Okay, and that is your goal when you're doing that. It makes every single equation true. Every single one is true. So this is a big system of inequalities. So your goal is just graph all the boundaries. Okay, you can call these boundary lines because that's what we said. These are all boundary lines. And then you have to say, okay, where do all the boundary lines, the shaded area intersects? This is your entire solution. Now, it would take you a minute to write all these down, and that's why we use the graphs to represent that.